Welcome everybody to this webinar on holding effective industry events, where we're going to concentrate on a specific example, which is the automotive industry. And let me just say that behind all of this is the IEEE Industry Engagement Committee, and a working group, a focused working group on events, which we call the World Technology Summits. And for today, the agenda is to tell you a little bit about the engagement committee, talk about the engineering profession as a whole, and where IEEE fits in, what I'll call an impact model, get into some of the details around events, and then start talking specifically about verticals and how events are built around them. And then I would say the bulk of our time today will actually be a panel discussion. We have 3 guests today. All of them involved very deeply with the automotive industry over their careers. We'll spend the bulk of the time there. And I would say sometime during that panel discussion, because our guests have hard stops at noon, we will actually start off with some questions and answers during that time. I have to say there are more view graphs than I can possibly go through today. So I'm going to sort of whiz through them. The actual presentation deck will be made available after the event. And let me just say we appreciate all of you who have joined and are with us today. So with that, let me just launch into the agenda. And the first part of it is to talk a little bit about the Industry Engagement Committee. Jessica Bien, who actually chairs that, is with us today, so she may have a little to say at the very end. But basically, the Industry Engagement Committee advises the Board of Directors. It looks at the products, events, anything to do with engagement with industry, how to improve that, how to, I would say, help IEEE with its strategy in dealing with industry. So I'm not going to go and read the charter in any detail. You can find it as part of the deck. Okay? But part of that is launching initiatives, and the World Technology Summits are one of those initiatives. So the next thing, which is an important part of background, is to take a look at what actually happens within the engineering professions that IEEE covers, the people, the technologies, the processes, the structure. It differs depending on what geography you are in the world. So I'm going to sort of concentrate a little bit about what we encounter in the US. And there's a lot of machinery that actually generates the statistics around that. Each region has its own bodies that do the same. Okay. So the first thing is, if you want to take a hard look at the United States, the National Science Foundation actually has hosts a organization within it that actually gathers these kind of statistics. And roughly speaking, here is what they show you. If you look at the U.S. workforce, roughly 150 million people, roughly 38,000 of those are part of what's called the STEM workforce. If you start looking at, I would say, some detail, what you find is in terms of occupations, around 6% are in science and engineering occupations. Of those, I would say IEEE covers roughly 6 million or so. Okay. And what's important to understand is that if you look at the membership of IEEE, it's actually a very small fraction of the actual professions that are involved. The next thing that's fairly important is to understand that when you look at the high-tech world that we sort of live in as engineers and scientists, where that happens isn't evenly distributed. So there are a lot of statistics in the reports that sort of indicate where the hot spots are. Uh, I'm going to skip this. If you then take sort of a more global view of things, and there are some surprises for me looking at these statistics. If I look at where people are actually, that STEM workforce is being created, China and India dominate. They have the larger population. The US turns out roughly 568,000 people a year. If you sort of do a deeper dive, you find roughly 140,000 of those are in the areas covered by IEEE. Russia, Iran, Indonesia, Japan, sort of a surprise when you start looking at some of these numbers. What is important is to understand in the various economies how much is actually being invested in R&D activities that we tend to cover. And what you find is that intensity, again, a little bit of a surprise for me, is highest in Korea, actually grown over time. This is the comparison between 2020 and 2021. So a lot of changes over the last 2 decades or so. Probably, I would say Asia Pacific has seen the biggest of those changes. If you then start to take a look at where R&D is being performed, and there are comparable statistics, let's say for Europe, that come from OECD. The UN tends to cover the rest of the world. But what you find is that in terms of basic research, higher education and the federal government sort of play the largest role. If you look at funding for basic research, surprisingly, again, around 35% of that comes from industry. If you start looking at applied research, the number shifts very, very highly. Much of that is now conducted inside of industry. If you look at the part where you actually build things, so this is performance, experimental development, deployment, all of that, uh, most of the dollars are actually spent within industry. Uh, the next thing that's fairly important is to take a look at trends. Uh, Again, I mentioned that the federal government plays a significant role. Um, if you take a look at raw budgets spent in terms of federal dollars, those have grown. If you actually account for inflation, they've actually slightly gone down. Uh, and then if you take a look at applied research, that's actually a diminishing role. Again, if you want to take a look at where the activity is, one measure is to take a look at patents. By the way, they're very important to IEEE. The single largest citations within the patent literature is actually IEEE publications. Again, there are very much geographic areas of concentration, and you find this pattern around the world. These are the skill sets people are looking for, so I'm not going to spend much time on it. But in looking at that structure and patterns, uh, I think what we have discussed over the last couple of years within the IEC is, what are the dynamics, what's actually going on? So one way of looking at this and trying to relate it to where people are actually employed and where most engineers spend their careers, what you find is you have sort of a lust to dust cycle. Starts off with notions, ideas, concepts, demonstration, all the way through product and services uh, deployment, operation, refreshment, and retirement. Uh, if you look on the right-hand side, those are the populations that tend to be involved with each step. The smallest of those is sort of that initiating phase. We need it. That's where innovation comes from. But in the end, the bulk of engineers spend their careers sort of in that practical part of the world. Um, so if you look at product and services a little bit closer, uh, that's where the bulk of that population is. Um, and what you find, and I just sort of want to really emphasize this, is while those populations tend to sort of concentrate on aspects of products and services that they serve, things really wouldn't work without having a uh, population, much smaller population of people who I would say are very much multidimensional. They're vectors of knowledge and idea, and their experiences sort of tend to span everything from the technical world of concepts and ideas all the way to the practical part of actually running a product and delivering it to somebody. There is a formal way of looking at this. I would say it comes out of the aerospace sector, and that is to look at products and services by TRL maturity levels. Uh, again, this is from trying something very simplified in laboratory all the way to having it work in an actual system in an actual environment. And it's sort of useful. So I think the bottom line is when you actually start looking at the IEEE population and what it does well, and it really does this extremely well, is concentrate on the first three parts of the equation of what we eventually enjoy as technology for humanity. Uh, and that is the scientific principles, establishing the engineering techniques and processes. Uh, but the big opportunity space for IEEE is actually getting a lot more traction with industry, where industry is investing dollars, and where people that we graduate and educate spend their careers. So with this, let me turn to meetings and events, because the objective of the IEEE World Technology Summits is to create events that engage with industry. And there are two important things to get across. Okay, what's a meaningful event in one sector and one geography will vary as to what that sector and geography is. And so our intent is to create the machinery that allows us to do this well across both sectors and geographies. In terms of the target community, I think from the picture I showed you previously, things are fairly complex. We are specifically focusing on product and services engineering, where value added is created by adding and addressing common problems, pre-competitive problems. And those are the problems faced by management and engineering staffs. And so one of the core principles we have for the events that we're trying to build is to make sure that the topic and the format of the events is actually based on the specific needs of industry. So to get a little bit more into this is to make sure that they serve those diverse segments, are conducted in a style that is focused on the industry participants, And that means that the subject and style in themselves are actually chosen by folks from industry, create positive and memorable experiences. I'm not going to go through and read everything on here, but very obviously to be responsible, make sure we also have and achieve a sustainable financial model. So there are five dimensions to this: technical content, social cohesion, essentially, the business model that goes along with it, how well it's executed, and the value that's actually delivered. Again, fairly complicated, but very simple principle. If one concentrates on a part of that cycle that I discussed earlier, what makes for a good meeting is to have the bulk of the folks present come from that portion of the cycle. They speak the same language. It's important to worry about geography and what sector it's in. And then the best interactions are with the adjacent processes that they either have to feed or they have to ingest from. In looking at this and engaging with industry, there are really two parts to things. Uh, Scott, could you actually go on mute, please? Thank you. Engaging with industry has really two dimensions to it. One is the value to industrial organizations, so one has to have one's eye on it. And the second thing is value for individual engineers and technologists in industry. And for both of them, it is return on investment and sort of what is the glue in terms of our content that keeps them coming back. So with this, we do have a focus working group. It provides three things: oversight, operations, and engagement. It's built to support multiple events. And by the way, from any of you who are listening in, who are IEEE volunteers, we more than welcome you to actually join the working group. We look at events as having six dimensions. One is sort of initiation of the idea and instigation, forming a team, making sure it actually ends up with the right content style and so on, and an execution plan, securing the speakers and attendees, executing the event. But events are not meant to be standalone. They're really to create long-term engagement. And so we also expect a follow-on plan as to what happens next. So I think with that, let me turn to specific verticals. Just sort of paint the following picture for you. It's a very complex world, okay? If you look at enterprise organizational structures, they vary. There could be a central organization, may have R&D associated with it. It may have engineering, manufacturing, marketing, and sales functions, and customer support functions that then support various business units. You also see conglomerates, large organizations that have a central organization, but business units that are very, very much self-contained. So understanding this variability also helps you figure out who is involved with who, what makes a valid event, how do you get the people who have some degree of cohesion and ability to interact with each other. Looking at all of this, we were going to look at a specific example, and that's automotive. Look at the question of how IEEE establishes relationship with practitioners, how you tailor things to their needs. Again, if you were to paint a picture and at least one view of it, of what the automotive industry looks like, you have what the OEMs, those are the plate names, the Fords, Volkswagens, Mercedes, large outfits like that. They actually assemble, design, promote, market, finance, automotive production, sales, and manufacturing. Tier 1 suppliers who really specialize in the industry. Tier 2 suppliers who provide specific components. And then Tier 3 suppliers who provide technology and things of that sort, but also focus on other markets. There is a lot more in that ecosystem. So to begin with, I think it's important to understand how complex this is. And then I would say from another dimension, which is economics, this tends to represent anything from 3 to 5% of a GDP of most countries at this point. If you look at automotive, lots of analysis literature. So analysts, consultants, and so on play a major role here. Same thing with associations, essentially. So you'll find a lot of literature out there that I hope our panel covers today. Okay. And if you look at specific concerns of what's hot, I took the numbers from a PricewaterhouseCoopers report that looks at the areas that are important because they sort of form the foundation for what the events in this area are likely to address. So I think that is sort of a very quick walkthrough, big picture. And again, I showed this view graph earlier. When somebody says the automotive industry, there are lots and bits and pieces to it. So depending on the experience of the individual, it's sort of like feeling the elephant in some ways when you have a discourse with them and they're actually not in that field. So with this, what I'd like to do is turn to our panel discussion. And today we have 3 people with us. The first is Scott McCormick. I think his background is here, but we'll do brief introductions. The second is Dan Isaacs, and the last is Joachim Teiber. Again, veterans of the automotive industry. And they play sort of a role at this point because each of them heads up or plays a important role in an association or a consortium where they actually deal with many, many different industrial organizations. Okay. So I think what I'd like to start off with, Scott, if you could unmute and maybe say a few words about your background and what the Connected Vehicle Trade Association and the other consortia you're involved with do. Okay?
Yeah, I was asked in 2004 by the 12 largest automakers to create a nonprofit trade association of entities that were involved in vehicle communications because they only dealt with tiers and they knew we needed a lot of different industries involved. And so I formed that organization. We're now going into our 21st year. We've done a number of significant things. We created the first test bed. It was the Connected Vehicle Proving Grounds back in 2007 and 8. We've created the Connected Vehicle Professional Credentialing Program that's had over 1,000 people worldwide certified. And then in 2019, the National Institute of Standards and Technology asked if I would create an association for people involved in teleoperations, which our board sees as a subset of this industry. We hold workshops, we hold our own summit. I've participated in as many as, I've given keynotes or chaired as many as 112 events in a given year. So there's a lot of variability, but there's a lot of commonality in terms of those events.
Okay, thank you, Scott. So let's do Dan Isaacs next. He's the CTO of the Digital Twin Consortium these days, but has a lot of background and experience in this area. Dan?
Yeah, thank you. Adam, and thanks for the opportunity to be on this panel. Yeah, my name is Dan Oziks. I'm the CTO and the GM for Digital Twin Consortium. And we were founded about almost 5 years ago. And that was really to look at not just set the foundational elements by cutting through the hype of what a digital twin is, but to really look at ways we can accelerate the adoption and extend the ecosystem. Where we started with about 50 members. Our main founders were Microsoft, Dell, Ansys, and some others. And then from there, we've now grown, and many of those members being partners of those different companies, but also having a strong emphasis around startups, academia. We've now grown into over 200 members, and we're in about, I think it's over 25 different countries. And one of the areas that we have within our working groups, that's how we're structured around verticals as well as horizontal, is in terms of mobility and transportation. And we will be talking about a new area we're going to be focusing on, and that's around software-defined vehicles. And I'll have more to say about that later. So thank you, Adam.
Thank you, Dan. Joachim?
So my name is Joachim Teiber. So I my origin is also in the automotive industry. I originally worked for BMW for many years, and I came over to the US around 20 years ago to form an automotive research and development campus in South Carolina, which became kind of, for me, the starting point to develop consortia in particular in cooperation with IEEE and SAE. And about in a little bit more than 5 years ago, we created a consortium around testing highly automated and fully automated vehicles. I was involved, similar to what Scott mentioned, test beds. So I was involved in my previous life at BMW in working with proving grounds for connected vehicles and electrified vehicles. So the idea of IMTS was to define capabilities of proving grounds that are being used to test autonomous vehicles. And we have engaged in regulatory developments for what is now called level 3 and level 4 driving. And our membership is about 50 members at the moment, who we are focusing right now to increase our membership to fleet operators and more OEMs, because we are seeing a transition from level 2 plus systems to level 3 and level 4 systems. Robotaxi deployment is becoming an important topic for the industry, and autonomous trucking. And so our focus is to develop test protocols, requirements for test beds, cyber-physical test beds, and the interaction with the regulators.
Okay. Joachim, thank you. So let's go on to the next thing, because in this panel, we'll actually sort of cover two areas. The first one, just to provide a little bit of background, is what are the current trends and challenges in the automotive industry? And that should be addressed by industry events. What are the hot topics? And again, with a focus on products and services. And then once we're done with that, which should take roughly half of the remaining time, is really start talking about the differences between academic conferences and industry events. Where does one create value for companies, and where does one actually create value for the engineers in the profession itself? Okay. So let me maybe start off with inverse order of things. Joachim, if you could maybe say a few words about what you think are the hot topics and trends at this point. I had briefly flashed something, but hadn't gone into any detail. Uh,
Yes.
if you could, maybe start off with tea, that's okay too.
So I think what is at the moment uh, a big topic in the industry in automotive is on the one hand the transition from ICE to electrification. And as you know, in particular in the EU, the regulators have set specific goals about market share that are expected to be reached for zero emission vehicles. And the adoption of consumers to buy electric vehicles is not following up to the goals. So a big topic is at the moment, how do we meet regulatory emission targets in North America, in the US in particular, through the administration change. We know that this goal has been de-emphasized. In the EU, there is a problem in meeting these goals, and then China has basically developed a strong market position in electric vehicles. And so this is one of the topics. The other topic is, I think, automation. So we are seeing more and more AI technology playing a role in end-to-end AI to support autonomous driving, automated driving. Um, for legal reasons, this has been started in level 2 plus systems. And now the big topic is, can we move into a large-scale deployment of self-driving vehicles? And as we are going into this, the key question is, are end users, can they trust the vehicle? So we call it AI assurance in mobility, which is becoming more and more a role. So the electrification is a key topic. The automation, fully automation in mobility is becoming a topic. And then more and more, the hot topic is also concerns around national security. So there are trade barriers. We are currently fighting a tariff war, as you know. So that means source of origin of components becomes a big topic. Where are these components being manufactured? Where are the vehicles being manufactured and assembled? I think an unresolved topic is, how do we deal with software? So we all know physical parts can be counted. Are we dealing with software? Is this a part? Is this not a part? How are we dealing with data that is being used to train the systems? So I think this is a variety of topics that I just mentioned that are being discussed.
Yeah. And I think what's important is they really are part of an ecosystem. So
Mm-hmm.
it's hard for a single OEM to do everything by themselves, essentially.
Yes, and maybe one more thing is in the chart that you showed before. So you had the description of the ecosystem, where the highest level is the OEM. And I made a comment that I think we have an additional layer, which is the fleet operator. So
Yep.
because the fleet operator is providing a service, is providing a mobility service. So it's not so much about owning a car, it's more using a service. And so from the move from using a car as a personal good that is being used to bring you to work or to do private things, to using a commercial fleet of vehicles that provide mobility services to end users. May they be commercial, I mean, may that be enterprise entities or end users, consumers. And I think this is a big shift at the moment.
Okay. So let's go on to Scott next, sort of on the connectivity front, because again, if I look at the statistics, almost everything we produce today has some degree of connectivity to it.
Yeah, I mean, if you look back 25 years, the only conferences we had was on navigation. You know, there were only 5 telematic boxes in the world in 2000. And an interesting thing about the industry events is that they evolve over time. We saw that when we moved away from having navigation, which communicates with the outside world, to understanding more about different telematic systems. With COVID, we all of a sudden had a lot of supply chain conferences that came on. And just before that, they started to understand the impact of cybersecurity once you open these portals. And now the cybersecurity conferences had pretty much moved away from being industry events to auto ISAC events. And even some places like Covisa, they don't even have a conference anymore. What they do is they just have a networking session because that's the highest value to their members, and they present at others' conferences. When we look at the communication aspects, you know, originally we were looking at satellite, cellular, Wi-Fi, dedicated short-range communication. About 2017, 2018, when the government failed to make a mandate to use DSRC, and with the growth in 5G, now they started to figure out, well, okay, we should have a conference on understanding what cellular V2X is and how that works. And of course, the challenge has always been is that the marketing of the capability of new technologies is generally run up the hype curve, right? And so it's kind of incumbent upon those conference organizers to provide balance when they do that. So that's my short answer.
Okay. So Dan, I think, what would be useful from you is sort of talk about both digital twins and maybe your background in the kind of silicon that modern automobiles actually use.
And I do agree with both, as Joachim and Scott have talked about. Number one, test beds, as well as being able to look at these different areas in terms of the ecosystem, which is really critical. So let's go back a little bit of the ways. When I was working with Ford, we were looking at it from the perspective of really ground floor opportunity, early stage EVs. And what does that look like in terms of the system? And one of the key areas that we were working to understand was really to not leave the driver stranded. We needed to have some type of a strategy that we would allow within the vehicle, would allow the driver to have some type of control, to be able to, in some type of situation, be able to get off the road and be able to continue. So one of the aspects around that, if you think about that, and this is where really some of the key areas are in terms of functional safety. And so going forward to the semiconductor company I used to work for, my previous company before tying in with the Industrial Internet Consortium, the sister consortium that we had at the time to the digital twin, was looking at specifically security, functional safety. This was both, and as you were hearing from Joachim, the different levels of autonomous operation. So critical to that is really being able to have the eyes of the vehicle, so to speak, and have the compute necessary to manage that in near real time, just because of the criticality of that. So thinking about it, looking at it from both ADAS, advanced driver assistance systems, as well as now the necessary compute to be able to manage that information and then be able to increase those levels of autonomy. So from going from the, if you think about it, it's hands off, it's feet off, it's ears off, and then it's mind off. So those levels of autonomy really that we're looking at and understanding it in terms of what is the compute necessary, what are the different interfaces, what are the types of scenarios, both from a functional safety standpoint as well as from a security standpoint. So looking at those different areas and then having the necessary compute to be able to become those eyes and ears of the vehicle, so to speak. So as I said, now we advance that forward and we look at that in the context of digital twins to be able to model these different scenarios in the virtual space. So modeling and simulation, critical, and then being able to look at that in the context of understanding the operation across these different layers or levels of autonomy. And so that's where now, as we see this progressing into these areas of software-defined vehicle. And what does that mean? What does that constitute in terms of the devices, in terms of the architectures, the connectivity within the device, and then again, being able to do that in a secure and safe manner.
Okay. So let me maybe spend a couple more minutes on sort of this hot area. And, you know, I think from what all three of you have discussed so far, the automotive world is very, very highly, I would say, multi involved with technologies from many, many different areas. And the question I'd like to ask is, how do industrial organizations deal with that range of subjects, okay, that eventually end up with a practical manifestation in something like a car and the way it's operated? Because today it seems to be everything from the latest in AI, all the way to making sure that the old disciplines of tolerancing, mechanical systems, all of that still work with each other. Okay. So Joachim, if I could throw that to you first.
Yeah, so I wanted to give you an example here. So what my appeal is, so to the industry side. So because we wanted to talk about also how does academia and industry work better together in a meaningful event. And what I noticed is, give you one particular example. I had recently an event where we talked about autonomous driving and autonomous vehicles blocking first responders when they are in action. You know, and what we noticed after we talked to some experts in the field of first responders is that the car companies, the OEMs, did not share their scenarios how to deal with first responders. And the reason why they kept these scenarios to themselves was that they think they have a competitive advantage. And so if we are working on standards, we need to share, we need to collaborate. And I think what is important in these events is that we are addressing these problems. Where do we need to collaborate and really go into the details of how do we find solutions? And so the academia side is typically open because they don't need to protect IP. The industry side is closed. And how do we get the industry side to open up, and then maybe help the academic side help to define solutions to get to standardized ways of protocols and engage. So what I wanted to say is that the IEEE in particular has, as we know, has many events where there are more academics than industry people. And then in other events where you have predominantly industry people, it's all about positioning themselves to others that they are leading in a certain area. But we need to have events where we have meaningful discussion and dialogue that then lead to an collaboration. So that's basically what I would highlight here.
Okay. Scott?
I have a little bit different view of how we've been doing it. We have found that in our workshops, which are generally smaller, right? They're 40 to 80 people and they're focused around a specific topic. We will bring in, and we have academic members, we will bring in the academic, let's say the topic is on voice technology, and they'll talk about where they're researching, and we'll progress with 3 or 4 other speakers up through the technology readiness level. It says, well, okay, who's got a device that they're building, who's got research going on in their company, who is producing a product, so that the participants can understand the arc and spectrum of what the work is being done, right? What are they researching that's new? And it's like, again, as I said, it's incumbent upon the organizer to make sure that whoever is talking about that, has put together that panel, that it's stitched together well so that people get a good understanding of that arc, right? Mm-hmm. The difference too is that at those workshops, we generally have a much heavier technical presence from industry. Whereas at our summits, and if you go to most major conferences, bulk of the people there are business development people. They're looking for, who can I do work with? They're not really looking to fund research. They're very rarely looking to take research out of the university and productionize it, because they don't do that in the public venue. So my view, and one of the ones that is very academic, is the Transportation Research Board. Mm-hmm. And they've been over the years working to say, okay, how do we address what we recognize are the needs of the industry? So they'll have a panel talking about, in Ilkam's point, what do they need in terms of better vision, right? Or the ability of the vehicle to hear, right? And then the audience sitting there from the academia will now look at it and go, hey, that's something that we have audiologists or expertise on. That might be something for us to work on to add new value to the space. Mm-hmm. And I think that's a big change from how it used to be.
Mm-hmm. Okay. I'd agree. I think the workshops are critical, because that does bring the ideas together into something more, that not just a concept. And then that can build out. We have one of our members has a whole training curriculum that they've developed, and it's really soup to nuts on digital twin. How do I start that journey? And then what are those different areas? And interestingly enough, the way they approached this curriculum and developed this was with a specific sponsor. So the students would actually have sponsorship, and that now brings that academic side, combines that with the real world, with the industry. And this was one case specifically around mobility and transportation. And so they have their curriculum building up to that, but at the end, there's a report out. And that report out includes the sponsor, and they've been working with them all along, and was really interesting to hear. Again, this was in a transportation management aspect for a small city in Florida. And the sponsor said, the comprehensive level of understanding that has been reflected through this this group that was tied into this specific training session, they said, we want to continue this. You've brought out points that we haven't really considered. So bringing that together, but bringing it together in a manner that extends beyond a workshop, it's practical, that can be used directly by by the industry, in this case, that city, for the transportation management. And we've seen that work across different industries.
Okay. Adam, if I could add one other thought, and sure. It's collateral to all of this, is that periodically, every couple of years, the trade association will get a number of our corporate members to sit down with our academic members for 2 reasons. The secondary reason is to talk about research areas they need. But the primary reason for sitting them down together is so that the industry can convey to the universities if they are satisfied with the curricula that they're providing their students. Because periodically they come out and they don't have the skill sets or the training that we need. And people, a lot of the students, a lot of the training that I do and that my partners do are based around filling in that cavity that we have, because academia has only slowly evolves its curricula. And if they can get input from what industry needs in terms of what kinds of jobs they're going to have and what skill sets they need, that's a much better way to get an engagement out of them.
Absolutely. And we have, for example, we have one of our members who now is working directly with industry. And they are saying, okay, this is the type of curriculum, these are the type of courses. So they're developing that in patterns so that those students will now be able to have those specific skills tailored. And this is all sponsored through the private industry, through this company. The other thing is we also have, as I said, a very strong academia and research working group within the consortium. And one of the members, being Purdue, has a program where they're working with industry, and industry says, we have these challenges, we're looking for this. So they put together, so this is through the provost office, they put together a team of postgraduates all the way through undergraduates to then go and tackle that challenge. They told me they are working with, I think it's 50 different universities across the states for this. And they tie directly into the industry, and they have over 5,000 students participating. Yeah. That's pretty significant when you think about now bringing that academia into the direct work for the private industry.
Okay.
I mean, yeah.
In some sense, I think we seem to have actually slipped into the second half of the discussion. So let's make it a little bit more explicit, okay? And again, maybe start with Joachim and move through Scott and then Dan. Okay, and that is, consider yourself in the shoes of somebody who's a product manager in one of the OEMs. Okay, what is the difference between the kind of meetings you would typically find in the research community versus what would be informative for somebody sitting in that seat?
I mean, so what I think the fundamental difference is that in the research community, you're constantly, let's say, analyzing new information, new research information, and you are under publication pressure. So you need, whenever you publish a paper, you need to come up with something new. Whereas I think in the industry, it's not just about constantly bringing new things and also getting things done. Maybe optimizing processes. At the moment at IMTS in the organization, we are dealing a lot with the topic of homologation. So how do you use, they call it digital homologation, so that you accelerate a type approval process that you need for highly or fully automated driving. How do you streamline these processes? This is typically not something that the research community is very interested in, but it is a big need in the industry. And then on the other hand, maybe when we need to analyze the details of regulatory changes and what are there new technologies that could be used in the process optimization, that's then something that the research community could be more interested in because they are developing a new tool. So this is something that I sensed is a difference.
Okay, Scott?
Given that we got only about 5 minutes left, and I want to reserve time for Dan, what I would like to say is people should look at how the University of Michigan's Transportation Research Institute, built a number of years ago, the MCity and their automated test bed there, and they have merged that with their engineering offices so that not only can the automakers and tiers come there and use their facility to drive on different roads, communicate in different ways, try out different things, but they're integrated with the researchers at the university who are looking at, well, okay, now I'm understanding what your problems is and how important it is to go forward. So having a center where they collaborate is incredibly important to advancing both that research and where the industry wants to go. Dan?
And I would definitely agree with that. In fact, we see that through another one of our members, which is University of Leeds. They have a research center there focused towards automotive and some of the latest, most advanced equipment that some of the automotive OEMs now work directly with. They schedule time just because of the simulator and the realism that's brought forward from that. So I think it's, again, looking at it in that context of how you bring industry into these different new innovative technologies and being able to actually have sort of where the rubber hits the road, right? So they can actually experience that. So the experiential aspect is critical here.
But and I want to also highlight here, is I've seen this because I have spent a lot of time at Imperial College in London. So if you have these one, so there you have sometimes an industry partner that wants to work with a university to show they're doing something. But then they are not really doing something because they just, it's a check in the box. I'm working with this particular university. But I remember there were a lot of issues in San Francisco, as you know, with robotaxi operators and first responder vehicles, which I mentioned before. And they may have engaged with MCity to check certain scenarios, but they didn't really bring it to a full ecosystem deployment with multiple partners that agree on a standard and then implement that.
Yeah. So let's do one thing, gentlemen. I think we're almost at the top of the hour.
Yeah.
There seem to be quite a few questions in the chat.
Mm-hmm.
So James, if you could maybe, I think if we could just open it up, and if you have questions directly for any of our participants, let's see whether we could do that. Okay.
Can you hear me?
Yep.
Yes.
Okay, great. So I'll start from, back to, Gustavo all the way down to the list. By the way, all the questions that have been placed in the chat, we have locked them in. So if we are unable to get to your question, don't worry, we'll go, come back and reach out to you via email. So Gustavo, can you hear us? I don't know, Gustavo's muted. So, okay.
Okay, you're not coming through quite clearly.
Okay, is any better?
Yes.
Yes, now it's better.
Okay, great. So Gustavo's question is, identifying and addressing industry pain points is crucial for improving IEEE outcome as business performance, enhancing customer satisfaction, and gaining a competitive edge, and more attractive to IEEE events. I guess that wasn't necessarily a question.
So is it a question or a statement?
Gustavo asked, what are our customer needs? Every business has two types of customers.
Yeah, I think the answer to that is really, as you've structured it, you've got industry people that are forming your agendas for your conferences, for your events. We have that. You guys have that. Those are the right people because they know what the pain points are. Right? And they're the ones that say, well, I want to have somebody get up here and give me a panel of an angel investor and an investment house and a venture fund and tell us what they're looking for to go forward. Investment. Somebody else will come up and say that, hey, I only want to address certain aspects of cybersecurity. I don't need to address, the whole world. I just want to talk about this area. So industry knows what its pain points are. It's a question of making sure you've got a vehicle to allow those industry people to communicate with your conference organizers so that they know what to plan.
Yeah. In fact, I mean, let me just say that for WTS, I mean, that's one of the sort of hypotheses for us is that it is in fact better to first form an industry panel and have them determine the technical agenda. Okay. And there's one other part to this, and I think Joachim may have mentioned it. I think so did some of the questions in the chat. The thing that is effective is to find what the common pain points are, because that's where you can have the best effect.
Exactly.
Okay. So James, you want to go on to the next question?
Well, we're at the top of the hour. I don't say,
Okay, so let's do the following thing. Let me just thank the panel for participating in this dialogue. We will sort of lock down the questions and send emails back to whoever asked them and publish them. The presentation will be made available on the website, as will the recording of this session. So thank you all for participating. And I think if Jessica, if you're still on, if you want to say a couple of words about IEC, that would be great.
Well, thank you, Adam. I appreciate you being our architect leading the webinar. And special thanks goes to our esteemed panelists, Dan Scott and Joachim. Thank you for your time and sharing insights and your wisdom. And for everyone listening, we hope this webinar would help you to create high impact industry events. You heard this is the example, right? The challenges, opportunities, and please think about it. And please let Adam or me or Jim know if you have any questions. Together, we foster innovation with the technology for benefits of humanity. Thank you again. And back to you, Adam.
Okay, so thank you. And I think, again, let me thank the panel and for all of the attendees. Thank you for taking the time to be part of this. And again, the invitation is open for you if you want to join any of our working groups. Thank you.